Good morning, everyone. So we're going to get started. My name is Paul Daniel Lee. Welcome to the OpenZFS Developer Summit 2016. We have a lot of great talks lined up for you today, so I'm not going to waste a lot of time jabbering. Without any further ado, here is Matt Ahrens to give the State of ZFS presentation.
Thanks, and welcome to the 4th annual OpenZFS Developer Summit. I'm Matt Ahrens. I helped to create this OpenZFS thing as well as ZFS back in the day at Sun. So first I wanted to thank our sponsors. If you are from one of these companies, please stand up. First off, we're going to go with platinum sponsors. These guys gave us enormous amounts of platinum. First off, Datto. Anybody here? I know there's some folks here from Datto. Thank you, guys. And from Delphix. Yeah, thanks. Thanks. Delphix is also my employer, so thank you very much. Intel. And Nexenta. Yeah. And OS Nexus. Thank you. Thanks to all of our platinum sponsors. We're keeping the platinum in a vault right below here, so no digging tools allowed whatsoever. And second, no explosives either. Next, thank you to our gold sponsors, IX Systems and Synedo. If you're from those companies, please stand up. Thank you very much. And also thanks to our silver sponsors from the FreeBSD Foundation, High Availability, and Ubuntu. Thank you. So all these sponsors enable us to put the conference on today. We have a bunch of things that they're financing besides the stuff that you're going to see and eat and hear. We have live video streaming going out on the internet right now. So if you have friends and colleagues that couldn't attend, point them to our website, open-zfs.org, where there's a live stream of this. We're also recording it. It'll be on YouTube. And this year I have been promised that we will have audio recordings that you can hear out of both of your ears. I don't know if anybody went to the recordings from last year. The sound quality was great. You could understand every word, but for some reason it only came out of one channel. So if you're using headphones, it only came out of one ear. But this year, both ears. And last but certainly not least, I wanted to thank some individuals who have spent a lot of time and their own effort on this. So first off, thanks to Aaron Holding. He has designed the OpenZFS t-shirts for the past 3 years. So you have him to thank for the really cool scene of San Francisco there on it. He designed all of our branding and t-shirts, and unfortunately he couldn't be here. But thank you very much, Aaron, if you're listening on the live stream. Next, I wanted to thank the Delphix PM team. So these are the folks that were doing all the behind-the-scenes work to get the food here on time, work with the venue, work with the AV folks, and all the other contractors. So thanks so much. Come out here, Catherine, Karen, and I don't know if Anastasia. Okay. Catherine did the vast majority of the work. So thank you very much. They're behind the booth giving out the t-shirts. Speaking of which, if you did not get your badge and t-shirt, during the first break, go out there. They're right near the entrance and grab one of those t-shirts. And then lastly, thanks to our volunteer, Julia Cisneros. She's out there manning the table right now, but thank you very much, Julia. Okay, so today we've mixed up the agenda a little bit from last year's. So last year, we tried to do 18 talks in 6 hours. If any of you were here last year, you might be aware that it was not exactly 6 hours. So this year, I have regained a little bit of my sanity, and we are planning to do a little bit fewer talks in a little bit less time, leaving more time for breaks, for folks to chat with the speakers and with each other in the hallway between the talks. And hopefully, we'll be able to stay on schedule. Some of those great talks that we didn't have time for today, we're going to have a few more talks tomorrow at the beginning of the hackathon day. So those are going to be updates on subjects that we've covered previously at the conference. I've asked the speakers to very, very, very briefly talk about what their project was. So you'll get a little taste of things that we've talked at previous conferences. There's video recordings of the previous years if you want to get more detail about those. But these are projects where you might have heard about some cool thing and been like, wow, that's really cool. Like, when am I ever going to get to use that? We're always talking about stuff that's in progress. So tomorrow we're going to have updates and hear about like design changes that have been made and what the current status is when you're going to get to use that cool stuff that we've been talking about from past years. And then for the rest of the day tomorrow, we're going to be doing a hackathon. The point of the hackathon is really to get developers together, which is what we're doing today, but to get them together really at the technical level, to be looking at code and working on projects with folks that they don't get to see every day in their, in their normal professional lives at work. So, we're not. We're working on systems, so we aren't expecting like a whizzy, animated flying things demos at the end of the day. But we do hope that people can write some amount of code, however small, and kick off some projects. Actually, a bunch of the stuff we're going to talk about later today are things that were first conceived at previous hackathons. And if you don't have any idea about what you want to work on, don't worry. We have a huge list of ideas. They're up on the website right now. So we'll definitely see those and talk about how you could go about doing those, even if you have very little experience developing ZFS. Cool. So I have a few announcements to make. First off, the point of OpenZFS has always been to make it a multilateral collaboration among a bunch of different companies, and organizations working together. So now but we haven't had any real formal structure around that. So now we're formalizing that a little bit by having the OpenZFS project join Software in the Public Interest as an associated project. So SPI is a nonprofit foundation, and they hold assets like leftover money, if we had any leftover money from this conference. And they do the same kind of thing for other projects like Debian and Jenkins. So we'd like to encourage all of you guys here to join SPI as contributing members as well. The members of SPI, they vote in the board elections, and they help SPI maintain its 501c3 nonprofit tax status. Okay, so hopefully that was a very boring announcement, but it sets OpenZFS up for long-term success, and it's actually enabled a much more exciting announcement. To talk about that, I need to roll the clock back to the beginning of OpenZFS about 3 years ago. Like any good open source project, the very first thing that we wanted to do was create a website. And we got this great domain name, open-zfs.org. It was obviously our very first choice of domain names. I don't know, maybe you pronounce it like open-zfs.org or open-zfs.org, whatever. However you call it, it was definitely the best domain name we could possibly have hoped for. But today, we're announcing the new home of OpenZFS, which is open-zfs.org. So thanks to Bill McGonigal for donating these domain names. And the domain names will be held by SPI, the nonprofit foundation, which is one of the reasons we were able to secure this donation. So Bill wasn't able to attend, but if you're watching, Bill, thank you very much for donating these domain names. And this is live today, so if you go to openZFS.org or .com or .net, you will reach our OpenZFS project page. Cool. So most of the conference, we're looking forward to projects that are in progress, that ideas that are being generated of what we're going to see in the future. I wanted to take a moment to reflect on the past. So I see that the strength of ZFS is really in its versatility. When we designed ZFS back in the early 2000s, we couldn't have imagined a lot of the use cases that people are building their companies on to use ZFS today. Remember back in 2000 to 2005, cloud computing hadn't even been invented yet. Netflix was a DVD mailing company, and streaming video also was completely infeasible at the time. But the foundation of ZFS as a very flexible storage system that can be used for all these different uses has enabled those kinds of things to use ZFS today. And each of these products that's built on ZFS, it only uses a small subset of ZFS's features. But as a community, I'm really proud of us because we've kept the focus not on focusing on one tiny thing, but focusing on the general purpose use cases and making sure that ZFS works well, not just for what I'm doing for my company or my one use case, but as a general purpose storage system. So I put together just a list of a few of the things that have been done in OpenZFS in the past few years. These are all things that have shipped. You look at this list, a lot of this is performance work. A lot of the stuff that we do with ZFS is improving performance. And oftentimes, performance optimization involves making trade-offs. Like CPU versus memory, or the performance of reading data, the performance of writing out data versus reading that same data in later on. Now, when people are thinking about performance, most of the time they're thinking about I'm trying to improve performance in this particular use case, right? Usually it's the one that's paying the bills. So one of the ways that we maintain this versatility of ZFS is by making sure that any performance enhancements don't inadvertently degrade performance of other use cases of ZFS. Specifically, we don't want to degrade performance of any other important workloads by too much. And this is a really vague and wishy-washy area. There's a lot of judgment involved in this. So I wanted to give you a couple of examples. So let's take a look at the three compression enhancements that we've done in OpenZFS. So quite a while ago, we added a new compression algorithm, LZ4. LZ4 is basically better in every way than the previous default compression algorithm. It compresses faster, and it compresses to a smaller size, and it decompresses much, much faster. So we made it the new default compression algorithm. We said there's really no downside to switching to this as the default. But even then, we only use LZ4 when you ask for compression. If you just use ZFS, you don't change any settings, we don't enable compression. And the reason is that even though LZ4 is really, really fast, there's still some CPU cost, and there's definitely some important workloads where doing that attempted compression and getting no benefit from it, like, for example, storing already compressed video files, that's a performance hit. So more recently, we added what we call embedded block pointers. So the idea here is that if you have data that's very, very compressible, that can compress down to fit into 100 bytes or less, then we'll embed the compressed data in the block pointer itself. And this eliminates even the need for the minimum size I/O that would otherwise be needed to write it. So we did this with a really specific, pretty narrow use case in mind of initializing or of writing initialized but otherwise unused blocks of databases. And it worked really great for that, especially because database administrators like to benchmark their storage systems by initializing database files. So this works really well for that use case as well. But we discovered that it's actually a pretty big win for a whole bunch of different kinds of metadata inside of ZFS. So for example, think of directories. Maybe your home directory has hundreds or thousands of files in it if you're like me. But most of the directories in your file system probably have only a handful of files. Think of your .ssh or .gitconfig directories. They have only a couple files in them. Most directories are like that, and those can be stored very, very compactly, which is a huge performance benefit for things like anything that needs to traverse the whole directory structure. So like find or doing backups, things like that. This is on by default. It's just used by everything. It's a straight up performance win in an unusually large or unexpectedly large amount of use cases. But looking at the more recent past with compressed arc, which just integrated very recently, with compressed arc, we're now storing data in memory, caching it. If it's compressed on disk, we're storing it compressed in memory. So this is a really huge win. Being able to store 2 to 3 times as much data in memory as we previously could. and getting much, much higher cache hit rates because of that. But this involves a pretty significant trade-off. We're pretty directly trading off between as we use the compressed arc more, as we use the compressed arc more, we need to do less I/O, so that's a savings, but we need to spend more CPU to decompress that data for every cache hit that we make. Like I said, for most workloads, this is a pretty big win because you're able to cache so much more data, and the cost of doing an I/O is so much more expensive than the cost of decompressing the straight from memory. But there's certainly workloads where doing that decompression is a significant CPU cost. So we went the extra mile to make sure that when if you know that for your workload you really need to use all the CPU for other things rather than decompressing what's in memory, you can turn off the compressed arc and you'll get the same performance that you were getting previously. So this is a case where there's a more significant performance trade-off. And we decided to, the default was to move us forwards and use more CPU and save more I/O. But we wanted to maintain the previous behavior so that ZFS could still be used in use cases where that are very CPU constrained and they can't afford that CPU. Great. And last, I wanted to mention that a lot of the work that goes to ZFS is not these kind of glamorous features that we can put up on the slide and applaud, but it's the small work of fixing bugs, making sure that all of the features work with everything else. So I took a look at all of the code in ZFS. So if you're using ZFS today, almost half of all of the code that you're using was written in the past 3 years by folks in the open source community. These are the folks that are mostly sitting in this room today. Some of them are sitting in this room today. A lot of them are behind the scenes, fixing bugs, improving performance, adding small new features that enhance usability. So I'd really like to end the talk by giving a round of applause to the folks who have put in this hard work over the past 5 years to make this happen.